Hello everyone, so for this video, I'm going to focus on the exploratory data analysis phase of data analytics. So make sure you read first the lecture notes to get some context on what we're doing here. So for this video, I'm just going to show the tools available in Orange Data Mining and in Excel, for example, specifically during the phase exploratory data analysis. So before we look into the tools, since we're going to be using a new data set for this video, I'm just going to show a little bit of a background on what the data I'm going to show you. So this is the Seoul bike sharing demand. So if you're interested in this data set right here, you can read some more about it from the source that I got from the UCI machine learning repository of datasets. So this is basically a data set that shows the frequency or the amount of bike sharing rentals for a specific service, specifically in the city of Seoul, Korea. And the data set looks like this. So let me import it for now. This one right here. So there are 8,760 samples here, 14 features. Let me create a data table widget right here. So you have the column date right here, which corresponds to the date for this specific sample. And then each sample in this dataset corresponds to a specific hour in a day. And the main feature of interest here would be this column right here called rented bike count. This would correspond to the amount of bike rentals that occurred on that specific hour. So for example, in this sample number 1 right here, this is January 12, 2017, specifically on hour 0, so that would be 12 a.m. There are 254 rented bike counts. And along with that data right there, it also shows the weather for that specific hour. So I'm not sure how this was exactly collected, maybe through some sensors or maybe through some secondary source, but for each specific sample right there, for each specific hour, there are corresponding temperatures, humidity, wind speed, visibility, point temperature, solar radiation, rainfall, snowfall, the specific season, and all of those would correspond to the specific weather characteristic of that specific hour. And you also have some other features right here that corresponds to data about that specific hour. If is there a holiday during that time, or is it a functioning day? I'm not really sure what functioning day means here. There's not a lot of information on the source right here. It just says non-functional hours or functional hours, but it probably means that the service is active during this hour. So if the service is active during this hour, then that would correspond to yes, it's a functional hour. If not, then it's no. So here's more information about the features in the dataset. Okay, so let's use this dataset right here to demo some of the tools in Orange Data Mining, specifically for exploratory data analysis. So if you're interested in the descriptive statistics of the features, you have multiple options that you can use right here. You can use the feature statistics widget, for example. Let me add a feature statistics widget right here. And this will automatically summarize feature statistics for all of the features that are available in your data set. So let me change this from selected data to all data right here so that you can view all of the features. So for these numerical or these quantitative features like rented bike count, it will show the histogram or the distribution chart of this specific feature, and it also shows the mean value of that specific feature, the mode, and the median as well. And it also has a measure of dispersion, which actually is neither variance nor standard deviation. But I'll show you how you can calculate this as well. So dispersion, it uses a different measurement than it's not variance or standard deviation. It also has minimum and maximum value as well, and the percentage of missing values for that specific feature. So it does that for all of the features in your dataset. So you can easily show the distribution chart as well, or the histogram. So for example, in rented bike count, you can take a look at the distribution right here, and you can see that the distribution is skewed towards the lower values. Unfortunately, there are no specific labels right here for the histogram, so it's not really the best way to show it. But the most important thing that you can use this for would be the mean, median, and mode, for example. And for the categorical variables as well, it also shows the mode. The mode is useful for that. So spring, for example, is the mode of the seasons categorical feature. For the holiday feature right here, the mode is the no holiday category. And there you go. So this will give you a bigger picture on the descriptive statistics of all of your features. So if you're interested in visualizing the box plot of your data set, it also has a widget for that. But before I move into this one, let me show you in Google Sheets as well. You can also do the same. You can also use the functions in Google Sheet to show the different descriptive statistics. So I started it out right here. So for example, if you're interested in the average of the dew point temperature right here, I can use the formula average, and that would correspond to the arithmetic mean or the mean, and dataset dew point temperature. Oops. So this one is the average dew point temperature, 4.07. So if you're interested in the median, you just change this formula right here into median. So the median is 5.1. If you're interested in the variance, you can just use the formula var for the sample variance, so 170. If you're interested in the standard deviation, you can use the formula stdev. Oops. So this one is just the square root of the variance, as we all know. And you can also use the formulas Kurt and these formulas for the kurtosis and skewness if you're interested in the distribution characteristics of your feature. So for the kurtosis, for example, you can use the Kurt function right here. So 860, so this corresponds to a positive or high kurtosis, meaning it's a leptokurtic distribution. And then for the skewness, you can use the skew. So negative 0.36, so it is skewed to the left a little bit. So you can do this for all of your numerical or your quantitative feature. So for your qualitative features, you can find the mode as well using the mode function. So for example, let's see, what are the qualitative features here? So this functioning day, holiday, seasons, these are all of the qualitative features. So I copy that here, paste values only so that it doesn't have any formatting. So the mode, I just use the function mode, and for the feature dataset, seasons, I made a mistake right here. Let me fix this for a bit. Oh, so I understand the issue now. So I think the mode function can only be used for numerical values in Google Sheets specifically. So if I use this in a quantitative feature like rented by count, for example, this will work. Yeah. So this is the mode. The mode of rented by count is 0. If you're still interested in the mode of a categorical or a qualitative feature, I think you can just use the count can just, for example, let me add here all of the unique values and seasons, for example. And then for each value, you can use a COUNTIF. Dataset seasons, and then the criterion is that it is equal to winter, for example. And this would give you a count on how many values are labeled winter, how many values are labeled spring, and how many values are labeled summer, and how many values are labeled autumn. And you can just look for the largest value right here. So spring and summer right here, there are 2,208 samples that are labeled spring and 2,208 samples that are labeled summer. So both of these values are your mode. So either spring or summer would correspond to the mode right there. Let's see if it has the same result right here. Yeah, spring and summer. So it displays spring for Orange Data Mining right here. So you can use either of these tools right here. It's easier to do it in Orange Data Mining, but if you want more control, if you want more descriptive statistics, then using a spreadsheet software like Google Sheets is more helpful, because Orange Data Mining, for example, doesn't have options to show kurtosis or skewness, but it's available here in Google Sheets. But if you're not really interested in those descriptive statistics, then you can just use the feature statistics of orange data mining, or you can use the box plot, for example. So this is where I stop. So let's demo the box plot right here. So for example, you're interested in the statistics of the feature dew point temperature. So these annotations right here would show the descriptive statistics of this specific feature. So this value right here, negative 4.7, of course, this would correspond to the lower quartile, and then 14.8 would correspond to the upper quartile, and then 5.1 right here would correspond to the median. So if you show dew point temperature right here, so it has the same values that it got. So just to compare the two different tools right here, if they showed the same values. So unfortunately, they don't label the specific values. You just have to sort of know. So this value right here, 4.07381, this is the mean, plus minus 13.0596. So this value right here, this refers to the standard deviation. And then 5.1 right here, this is Q2 or the median. And then negative 4.7 is Q1 or the lower quartile. And then 14.8 is the upper quartile. So the box plot also shows that. It also shows the minimum and the maximum values, but it doesn't label it specifically. So you can use this as well. So you can change the features. For example, if you're interested in rented bike counts descriptive statistics, then you can see right here. So its mean is 704.6. Its standard deviation is 645. So it has the same values right here. It's just rounded off. Its Q1 is 191, its Q3 is 1065.5, and its median is 504.5 right here. And one of the things that is useful for box plot, you can use it to compare different groups of data, which can reveal the relationships between, or the relationship between a categorical variable and a quantitative variable. So for example, you're interested in the relationship between rented bike count and seasons. You can just select here a subgroup. So by default, it would select none for that one. But if I select seasons right here, it will create a different box plot for every possible category in seasons. So seasons has 4 possible categories: autumn, spring, summer, and winter. It shows it right here. So this is the box plot of the values labeled autumn. This is the box plot of the values labeled spring. And this is the box plot of the values labeled summer. And this is the box plot of the values labeled winter, for example. And this will show you which specific category is associated to lower values, for example. So winter, the box plot for winter is to the left of everything. So you can sort of gain the insight that during winter, there's not a lot of bike rentals. You can even check compare medians and compare means right here, and it will label the median or the mean, and it will even order it from the lowest and then the largest mean, for example. So here, these lines right here will connect to the median of this specific box plot. So here you go. So winter has the lowest bike rentals, spring has the next lowest bike rentals, autumn has the next lowest bike rentals, and then summer has the most bike rentals, for example. So the mean bike rental count for summer is 1034, and then during winter it goes as low as 225.54. And the box plots also even reveal the comparison of the dispersions for each of these categories. So winter, for example, has low dispersion. That's why the box or the interquartile range of this box plot right here is narrow compared to a wider interquartile range of spring, autumn, or summer. So for these three seasons right here, they have similar dispersions. That's why their standard deviations are around 600 to 700. So again, you can use this box plot right here to show either relationships between a categorical or quantitative variable, and you can also use them to reveal descriptive statistics. So let's change this. For example, if you're interested in temperatures for these different seasons, so winter, it kind of makes sense right here that winter has lower temperatures compared to summer right here, which has higher temperatures. Humidity, there's not a lot of difference, but winter has low humidity while summer has high humidity, which also makes sense. Wind speed, there's not a lot of clear differences between the four groups of data, but you can even see it right there. You can compare rented bike count with the holiday to check if there's a meaningful difference between the amount of bike rentals during holidays and non-holidays, for example. So here there's a little bit of a difference. So the median bike rental for non-holidays would be 524. So this value right here. And then the median for the bike rentals for holidays would be 240. So there's some meaningful difference right there. So that's a useful insight that you can glean. So that's what's good about the box plot right here. You can really add a dense amount of information. It can include the descriptive statistics. It can include the dispersion. It can include the min to max range, for example, and so on. Yeah, you can even uncheck this one right here. If you're just interested in the visual comparison of these two box plots, for example, you can remove the annotation so that it's not as cluttered. There you go. Okay, so moving on. So if you're interested in the specific distributions of the features, you can also use the widget distributions right here. If you're interested in the histograms, for example, you can use this. And it's a more detailed version of the distributions that you can find in the feature statistics widget right here. In this widget, you can control the width of the bin, how large the ranges of each bin is. You can even split it by a specific category. So for example, this is showing wind speed, and it shows that this is the distribution of the wind speed, and it's a little bit skewed to the left, for example. Let's see. Skewness of wind speed is 0.89 right there. And if you're interested in, let's say, rented bike count, for example, this is the distribution, and it shows that for all of the samples, the most frequent rented bike count is around less than 100. So if you hover these bars, it will show you the specific values. So between 200 and 300, the amount of rented bike counts that fall under that range is 962. Let's say you're interested in the visibility, for example, then it has this distribution right here. So visibility, most of the values fall in the range that is greater than 10 meters. So this area is apparently not that snowy because the most frequent snowfall value falls below 0.2. Temperature right here, the most frequent temperature would be around these ranges right here, specifically this bar between 20 and 22. So you can use this right here, distributions, and you can even split this, for example. For example, if you want to see the different distributions of rented bike count, comparing it to the holiday categorical variable. So it will generate the legend for this one. So these are the frequencies for the holiday distributions, and these are the frequencies for the no holiday distributions. So if you want to compare two different features, let's say you want to compare qualitative features, you might be interested in creating a contingency table. So there's no direct way to automatically create a contingency table, but what you can do instead in Orange data mining is to create a pivot table. So from this data table, for example, I can connect that into a pivot table widget. And you just have to change the pivot table so that you can create the contingency table that you're looking for. So for example, I'm interested in comparing the two categorical variables. Sorry. Let me change this first. Instead of selected data, to all of the data right there. There you go. Accidentally collapsed this one. So let's say you want to compare seasons, the relationship between seasons and holiday, for example. And then specifically the counts. So it doesn't really matter what you choose right here. If you're interested in the contingency table, you can use either of any of these features. It actually won't change the values that you get right here because these are just counts anyway. And this one will basically create the contingency table for you. So here in the combination of categories autumn and holiday, there are 120 samples that are labeled both autumn and holiday. Spring and holiday, 72 of them. Winter and holiday, 192 of them. So this would give you insights on what the associations are. So this will basically tell you, for example, that there are a lot of winter holidays compared to summer holidays, for example. There are a lot of autumn holidays as well compared to, again, summer holidays. And I can label this, for example, contingency table. Holiday versus season. If you're comparing two quantitative features, you can use a scatter plot. So for example, you want to compare the rented bike count with the temperature, for example. So it gives you this scatter plot right here that you can control. So you can automatically change the size of the points, for example, if you want bigger points. In my opinion, I kind of want smaller points than these, but this is the minimum size of the points. You can change the oh no, this is for the different attributes. You can change the opacity of the points. The opacity helps you sort of visually represent the density of the points in a specific area. Because if you give it some, if you make the opacity lesser, meaning the points are now semi-transparent, then it gives you an insight that the darker areas are more dense, for example, because there are a lot of samples stacked inside there. The jittering slider right here will basically sort of give it some randomness. It will help when there are a lot of points that are stacked on a specific point in the plane. So the jitter will make it, give it a little bit of randomness. This is especially useful if you are comparing quantitative features and qualitative features. So for example, let's stay in quantitative versus quantitative first. So let's say we're comparing rented bike count and hour of the day. So you end up with this one, for example. Rented bike count and let's say humidity. Rented bike count and let's say rainfall. Let's say temperature. You're interested between temperature and visibility, for example. So let's say temperature and snowfall, for example. So when you're changing the different features that you're comparing, so it's helpful to tweak the opacity sliders right here depending on the appropriate comparison that you're looking for. So for example, in this case, if you're interested in temperature versus snowfall, it becomes harder to see the points in this region right here. So it might be useful to increase the opacity, for example, and to give you some kind of insight. So these attribute settings right here will let you change the color depending on a specific category. So for example, if you want different colors for the different seasons, unfortunately it doesn't show the here you go, show the legends. So the samples that are labeled summer are colored green. The samples that are labeled spring are colored red. The samples that are labeled autumn are colored blue, for example. So this will give you insights, for example, that within these regions right here, lower temperatures would correspond to samples that are labeled winter, which makes more sense because during winter, the overall temperature is lesser. While this region right here would correspond to temperatures of samples that are labeled autumn, for example. So let's show again rented bike count and temperature, for example. So this one is an interesting comparison between these two because here there's some kind of relationship between them. So it's not the most direct relationship, but you can sort of see that the higher the temperature, the higher the rented bike count is. So it sort of gives you the insight that when it's hotter, people usually tend to rent bicycles in this tend to use the service for bicycle rental, while during lower temperatures, for example, then they don't really use it that much. It has a lesser amount. One thing that you can do with the scatter plot, by the way, you can select specific regions. So you can drag your mouse, for example, and it will select a specific region. And then the selection can then be connected to, let's say, a data table, for example. And then you end up with 1,690 samples here. And these samples will correspond to the selected samples that you highlighted in the scatter plot. So just in case you're interested in a specific region, then you can do something like that. If you're comparing qualitative and quantitative features, you can also use the scatter plot as well. So you just need to change, let's say, the x-axis. You will replace it with a qualitative feature. So for example, holiday and rented by count, for example. Let me remove the colors for now. And the highlighting. So let me reduce the opacity a little bit to reveal the densities. And this is where the jitter slider is useful, because without the jitter, all of the points are not scattered. They're like stacked on top of each other. To avoid that, you can increase the jitter right here to give them a little bit of randomness. So the more you increase this one, the more spread out they become. It doesn't change the data set, it's just a visual representation, it's just a visual change, just to make it easier to show the different densities. So for example, comparing these two, so let's say you replace this with seasons, for example. So here, let me reduce the opacity some more. So here you can see that during winter, right here, there's not a lot of bike rentals compared to the other seasons, of course. So maybe because it's too cold, so the people don't really go for bike rentals. Maybe they're commuting, for example, during the winter season. You can compare rented bike count or seasons with temperature. So here there's a meaningful difference between their distributions. So you can see that the winter has a lower distribution of temperatures, while summer, of course, has a higher distribution of temperatures, which of course makes sense. During summer it is hotter. So you can use this as well, this scatter plot, to compare the relationship between a qualitative feature like seasons and a quantitative feature like temperature. And just as I showed in the box plot, you can also use the box plot to do the same as well, bivariate analysis to compare qualitative and quantitative. So this is a similar graph that I got. Season and temperature. There you go. So these are one of the strengths of orange data mining. It's very easy to generate all of these visualizations. If you're gonna do the same in Google Sheets, for example, your options are a little bit more limited. So for example, if you want to use Google Sheets to create a visualization, a histogram visualization, you can insert a chart, for example, and then there is an option for a histogram chart right here in the other section. And you can just change the data range right here. So this one would correspond to the entire table. So I'm going to select this one and then press OK right here and then select a specific feature. So if I'm interested in rented bike counts, so these are the distributions. You can even customize this histogram chart right here to change the bucket size. The bucket size will correspond to basically the bin size. So the larger the bucket size, the wider the ranges are that you're looking at. Usually auto is intuitive right here. Basically Google Sheets will automatically figure out the most appropriate bin size for you if you select auto here. You can also use Google Sheets' own version of the scatter plot, for example. So insert chart and then you just select scatter plot right here and then select the appropriate data range right here and then change the x-axis into, let's say, rented bike count. So here you can change the opacity if you're interested in showing the densities, for example. So you want to make it lower, for example, to make the dense areas more obvious. At least this one you can make it as small as 2 pixels. There you go. You end up with a chart that looks like this. So this one is temperature and rented bike count. So here you can see the relationship between these two variables, for example. Actually, I like this more compared to the chart that we got from Orange Data Mining, since we can easily control the size of the points in the scatter plot. So I kind of end up liking this more. But anyway, it will be up to you, whichever you choose. It doesn't really have a specific box plot option. Google Sheets, I mean. If you want a box plot, you can use this one right here, the candlestick chart, but you have to do some editing right here to generate the box plot. It won't automatically generate the box plot for you. You have to individually calculate the interquartile ranges, you have to calculate the median, and etc. Because it's not, the candlestick chart is more meant for other purposes, but it can be repurposed to create box plots. Anyway, let me go back to the scatter plot because I like that one. So if you want to save this, for example, you can download chart, for example, and you can choose to download it as an image or as a PDF document or as an SVG, for example, and it will download an image for you, and you can save this for a presentation, for example. You can also do the same in Orange Data Mining. So let's say you're interested in saving this scatter plot right here. Sorry, I keep on What did I do? Let me reset this first. I think I ruined it. So here, there's a save button right here to save this image. And you can just save this, for example. Let me show that one. There you go. So these are all the options you have if you're interested in performing the exploratory data analysis. Thanks everyone.